Welcome, ladies and gentlemen, and we're going to be starting a new unit. I think this is our unit 4, but it's actually chapter 7 in the textbook. So we jump around a little bit in this course, this is our 4th unit. We had our first unit test before we left. We had our second unit test the week before we left for March break. And then we've just finished our trigonometry and Pythagorean theorem unit, and now we're on to our 4th unit, but again, chapter 7 in your textbook, so don't get confused by that. Okay, so let's see what we have here. Quadratic expressions. So we're going to go back and do some more work with algebra. I'm picking and choosing what's the most important topics for us for next year, and this is definitely up there. So a numerical coefficient, let's think of that word, numerical. It stands for number. So a number coefficient. Now a coefficient is the number that's in front of a variable. So a numerical coefficient, that's a new term that we need to understand. A numerical coefficient is a number that multiplies the variable. So it's in front of the variable. Now remember, when we show multiplication, there's all sorts of ways of showing multiplication. Here's one way of showing multiplication. We could show 3 times 4. And that's a perfectly fine way of showing multiplication. We could also show multiplication as 3 times 4. We could also show multiplication as 3 times 4. These are all different ways of showing multiplication of 3 times 4. Now, when that 4 becomes a variable, let's call it an a, you could have 3 times a. You could have 3 times a. We could have 3 times a. And we have a new one that could be 3 times a. Now, we can't do that with numbers, because if we write it like that, we're not, that's not 3 times 4 to us anymore. That's 34. But this is still 3 times a. And what all of these mean is 1, 2, 3 a's being added together. 3 times a. I've got 3 a's. Okay, so that's sort of where we're going. Now, when that variable isn't a, when that variable might be an x, things get confusing, don't they? They start to look a little confusing. So we talk about 3x. We stop using this symbol anymore for multiplication when we start using more algebra, because that symbol for multiplication and the symbol that we use for x starts to get a little confused. That's one reason why sometimes in some books you'll see a dot, and that dot stands for multiplication whenever we have x's around. And that's just a fancy x. I just sort of, made it kind of look kind of neat. Okay, so a numerical coefficient is a number that multiplies the variable. Identify the numerical coefficient in each term. So we're looking for the number that's multiplying by the variable. So in this case, the number multiplying the variable is simply the 3. So the numerical coefficient is 3. And in this one, the numerical coefficient, now you have to take into account the sign. So the numerical coefficient is actually -5. That's it. That's all there is to those. A polynomial. So a polynomial. Poly means more than one. So a polynomial can have 1 term, 2 terms, and 3 terms. Now, if they have 1 term, they have a special name. We call them a monomial. Mono for 1. If they have 2 terms, we call it a binomial. Binomial, like bicycle, for 2 terms. Trinomial, like tricycle, 3 terms. And if they have more than that, we don't really go on. We just call them polynomials. More than 1 term, and they continue. So, 2. Identify each expression as a monomial, a binomial, a trinomial, or if it's not any of those 3, then we give it the generic term of a polynomial. Okay, so 2x squared plus 3. So what is a term? Well, a term is anything that's separated by an operation of addition or subtraction. So this is a term, and this is a term, and it's separated by this operation of addition. So these have 2 terms. That will make it a binomial. And that's all there is to this. So now you look at B. Now that's only 1 term. It's 5 times x. There's no adding or subtracting. There's no other terms being added here. So you're looking at a monomial. learn how to spell these guys. And then we have another one here. Let's take a look. I've got a negative 3x squared, that's one term, plus 5x, that's another term, minus 1. So that's three different things that are here, okay? And that's important to realize. So that's a one term, that's two terms, that's three terms. So that's a trinomial. And over here, we've got the x squared, which is a one term. We've got a 1, which is another term. We've got this other term. Now, we've brought in a new idea here. We've got 3xy. So 3 times x times y. But again, that's only one term. And that's a term. Sometimes when I go into this, you're going to see me sort of talk about terms. I'll give them little different shapes around them. So that would be one term, that would be two term, that would be three term, and that would be the fourth term. And each different shape means that each term is different. Okay? So that's four terms, so we're going to call that a polynomial. Yay! All right. Well, we want to extend our idea of multiplying and dividing to work with these terms. So this is 2 times negative 3p. 2 times negative 3p. Now, what it means is very different than how we're going to do it. What it means is that you have a negative 3p plus another negative 3p. That's what it means. You have two negative 3p's. So if I have negative 3p plus another negative 3p, I have two negative 3p's. Another way to think about that is I have negative 6 p's in total. I've got negative 3p's here plus another negative 3p's, and I've got negative 6p. Now that might have been confusing. I might have lost you for a second. Rewind the video, go back over that, see how this works. But that's very different than how we're going to actually calculate this value. What we're actually going to do is simply multiply. So I've got 2 times negative 3 is negative 6p. And that's how we're going to get the final answer. But make no mistake, this is what's happening. So here we go. We have negative 2 times negative 5q. So I take that negative 2, I multiply it with the negative 5. Negative times negative is positive. 2 times 5 is 10q. Yay! All right, let's look what's next. 2x times 3x. Now what's really happening here is that I've got 2 times x times 3 times x. The order of multiplication does not matter. I can put these in any order that I want. So I could do 2 times 3 times x, which means that I could do 2 times 3, which is 6, and x times x, which is x squared. That's your final answer. Now, what it means and how we actually get the answer might be two different things. I'm going to take the 2 and I'm going to take the 3 and I'm going to multiply them together. So 2 times 3 is 6. Boom. I'm going to take the x, I'm going to take the x, I'm going to multiply them together, and I know that x times x, there's that dot, is x squared. Now, x times x is not 2x. Let's be very, very clear on that. If I have x plus x, that is 2x. But if I have x times x, that is x squared. All right. Moving on. Negative 12x divided by 6. Okay, so negative 12 divided by 6. We can write this a different way if we want to. That might be easier to see. I've got the negative 12 divided by 6 is going to be 2, negative 2. And it's going to leave me with negative 2x. The x stays on top. But the negative 12 and the 6 we're able to reduce. Now remember, this comes about because there are two 6's and 12. So with this one, if I have negative 12x over 6, this is actually the same as 2, 6x over 6. Let's be very clear here. This 2 times 6 is the 12. If I have a 6 on top that's multiplying and a 6 on bottom that's dividing, they're just going to reduce out, leaving me with negative 2x. So a similar idea is going to happen up here with the 25. Let me show you how it works. Just need to fold my piece of paper over. So I've got negative 25y squared over negative 5y. So what I'm going to do is negative 25, I know, is negative 5 times positive 5 times y, all over top of negative 5 times y. Now, I wrote it out differently, didn't I? And we won't be doing this all the time, but you need to be able to see where this is coming from. So this is negative 5 times 5 is negative 25. Y times y is y squared. Negative 5 times y. Now, we can get rid of anything that's going to reduce. I've got a negative 5 up here and a negative 5 down here. Now, they reduce and give you ones, not zeros. Let's be very clear on that. A 3 divided by 3 is equal to 1, not 0. So we don't want to put zeros there. I've got a y on the top multiplying. I got a y on the bottom multiplying. They will reduce out. What that leaves me with is what's left. 5y, 1 times 1, or simply 5y. That's why those ones are important, right? If you had left zeros down here, then we'd be in trouble. We'd be dividing by zeros, or we'd have zeros up here and have zeros in our numerator, which is also a very bad idea. Now, how it actually works and what we do to get the answer might be two different things. Negative 25y squared divided by 5y. 25 and 5. I know that they reduce. There's 1 5 and 5, and 5 5s and 25. The negatives also cancel out. I've got y squared on top, so I've got 2 y's on top. I've got 1 y on the bottom. Where are there more y's? On the top. How many more y's are on the top? 1 more. So when they cancel out, I'll be left with 5y. Okay, moving over. Let's take a look at number 3f. 10x squared over negative 2x squared. I'm going to tell you that the answer is negative 5. And if you can get that answer right away, good for you. Let me show you what's happening, and some of you may need to do a little bit of work at first. I've got 10x squared over negative 2y squared, or x squared, sorry. So what's really happening here is this 10 can be broken up into a 2, a 5, and I can leave that as an x squared, because on the bottom, I can also leave that one as an x squared. Now look what I did with here, this negative. I made it negative 1 to move the negative out so it wasn't in the way of me noticing that these 2's are going to reduce. This is x squared on top, this is x squared on the bottom, so they're going to reduce. And when I talk about reducing, I'm talking about canceling. And again, it's the idea of 3 over 3. 3 divided by 3 is 1. And that's just reducing that. Okay? So what's that going to leave us with? 5 over negative 1. Now, remember what we said before we broke for March break. We know that a positive divided by a negative is simply a negative. So that's simply going to be negative 5. 5 divided by 1 is 5. And if I've got the negative down here, it's the same as having the negative in the top. Both of these are negative. Okay, good work. Number 4. Only like terms can be added or subtracted. So we can only put like terms together or add them or subtract them if they have the same variable coefficient. The variable part has to be the same. So let's take a look at this. What I have here is 2x plus 6 minus 4x plus 8. So if I'm going to put that together, and I think we've done this work before. I think we're okay with this, but let me just be sure. If I've got 2x plus 6 minus 4x plus 8, some of these are like terms and some of them aren't. Well, the like terms are the 2x and the negative 4x. Those are both like terms. And the 6 and the 8 are also like terms to each other. They're both new numbers. So if I wanted to rearrange this, I could. I could make it 2x minus 4x. Notice I had to keep the negative with the term. And then it would be plus 6 plus 8. So all I did was rearrange the order here. But what I've noticed is that I've got 2x's, subtract 4x's. Well, if I have 2 subtract 4, that leaves me with negative 2x's. I've got 6 plus 8, that's going to give me 14. And that's it. You've combined like terms. These guys were like terms, these guys were like terms, we put them together. Now, You may or may not want to rearrange them. So for example, writing this step is completely optional. I'm not going to do it after a while. I'm going to simply say 2x, take away 4x is minus 2x. 6 plus 8 is 14. And I'm going to go straight to that answer. But it's up to you. Let's take a look at this one. So first of all, first step is to figure out what like terms are. Well, x squareds and x squareds are like terms. X squareds and x's are not like terms. They are not the same. The x and these x's are like terms. So 2x squared plus 3x squared gives you a total of 5x squareds. I've got 2x squareds here. I'm going to add 3 more x squareds. I've got negative 4x's. And then I have negative 11x's. So negative and a negative, they're going to go together to give me more negatives. And I'm going to have a total of negative 15x's. And that's my final answer. Okay, the next one. They're getting tricky here with brackets. Don't worry about the brackets. Now, we've talked about these before. There's an invisible one. There's a couple ways of dealing with this. And I think the easiest is to realize that there's an invisible one here. This means x plus 4 plus 1 bracket. That's what that 1 stands for, 1 bracket. And we can expand. We can use the distributive property to get rid of the brackets. So this will become x plus 4 plus x squared minus x plus 5. That was a lot of work just to drop the brackets, but it's needed because when we have a numerical coefficient in front of here other than 1, we're going to have to do more work with it. So I've got x subtract x. Well, that's no more x's. Now I can write 0x if you really want to, but it seems kind of wasteful. I've got 1x squared, so that's sticking around. I've got a 4 plus a 5, so that's going to be 9. And that's it. That's all there is to that. Okay, I'm going to stop here, and then we'll flip it over, and we'll finish off the last few examples.